Okay. Yeah, this is the standard. Uh-huh. So it says the point is at 6, negative 2 lies on the curve. So we have 6, negative 2 lies on the curve of y equals 2 over 5 minus x. Okay? And use your calculator to find the slope m, pq, of the secant line correct to 6 decimal places for the following values of x. Now, you can do this by the values of x, because you know the point. So one way to do what you're saying, is to do exactly what you said. So one way to do it would be for every single part to put in for the value of x into the function, so 2 over 5 minus 5.9, and find the corresponding y coordinate, and then find the slope 6 times or 5 times or whatever it is. Okay? But you can also find a general expression for the slope. So you know that you have, so if you figure out that you have a point 6, negative 2, right? And your other point is x, whatever the x is, you don't know what it is, but it's x and 2 over 5 minus x. Okay? Your point is some generic x and 2 over 5 minus x. Now, what we're going to do is we're going to derive a general expression. I'm going to send you this when I finish writing it.
Okay.
Derive a general expression for the slope, okay? So you have of the secant. So, and then I'm gonna show you a trick to get your answers faster by using your calculator. So what we're gonna do, we know that the slope is y2 minus y1 over x2 minus x1. Now what I'm gonna use is it's gonna be a complex fraction because my function is fractional. So
Right.
y2 is gonna be the expression 2 over 5 minus x. And y1 is gonna be negative 2. So I have 2 over 5 minus x minus negative 2. And then x2 is gonna be x minus 6. Now, I've got this kind of bulky expression. Now I'm just going to do algebra
Yeah.
to clean it up. So I have 2 over 5 minus x plus 2, because that double negative switches the sign, x minus 6. Now, there's a couple of ways to clean up the complex fraction, okay? I'm going to use the LCD method. So I'm going to multiply the top and the bottom of the complex fraction by 5 minus x. So I'm going to have m is equal to 5 minus x times the entire numerator, which is, and I'm going to do it by each term.
Right.
So 5 minus x times 2 over 5 minus x
It's 2.
plus 2 times 5 minus x over 5 minus x times x minus 6, because I have to multiply the entire top and the entire bottom by 5 minus x. So I get 2, as you said, because they cancel. 2 plus 2 times 5 minus x
10 minus.
over that. That's going to be 2 plus 10 minus 2x. And then the bottom part, I'm going to go ahead and FOIL.
Wow.
You don't have to, but
Because the terms will cancel, right?
possibly, but I think I'm going to, is it going to cancel? Let's see.
Yeah, because I did do it this way, and I
Okay.
ended up getting the two terms x minus 6.
So I get, okay, let's see. So 2 plus 10 is 12. So I have m is equal to 12 minus 2x over 5 minus x times x minus 6. And then I can factor out a 2. So I get 2 times 6 minus x and 5 minus x over x minus 6. So actually this works out really well because this becomes, now the thing you have to be careful of is 6 minus x and x minus 6.
Mm-hmm.
So they cancel, but they cancel with a -1, right? Because they're opposites of each other.
Okay.
Do you remember that?
There's no way to change 6 minus x to be x minus 6, because if you multiply it by a -1.
Well, actually you can. If you want me to show the step, I can. What I did was I have 2 times. Now, if you think of x minus, first of all, rewrite, don't factor anything out, just rewrite it. 6 minus x is the same as -x plus 6. Would you agree with me?
Yes.
Okay, so leave it in parentheses. Now, leave the bottom the same, 5 minus x, x minus 6. Now, the next thing you do, leave the 2 on the outside, factor out a -1 from that -x plus 6. So if you factor out a -1,
Mm-hmm.
and then you open another parenthesis, you'll get x minus 6. You see that?
So does it become 2 times x minus 6 is just like
So
that?
it's 2 times -1 times x minus 6. Because
Oh,
I pulled out a -1, right?
okay.
When I had -x plus 6,
Yeah, I
-x
see.
plus 6, pull out the -1. So essentially you have -2 times
Yeah.
x minus 6. And then you have 5 minus x and x minus 6. Now, the general expression for the slope of your secant line is going to be -2 over the x minus 6's will cancel, and you get -2 over 5 minus x.
Okay.
That's the general now, if you want to clean that up even more so you don't have as many negatives, you can, but it's not necessary.
Okay, I think I did get that same.
Now,
Oh, yeah.
now comes the easy part. That was the hard part.
Really? Like, oh my God.
That was the hard part, actually.
That's the fun part for me. For the most part, I just get mixed up with negatives. If you haven't noticed, that's my.
So that is, we did all the work. We already calculated the slope. That's why we did y2 minus y1, all that, right?
Yeah.
So this expression is your slope.
My slope.
Now, all you have to do, I say that like but all you have to do, let me show you something. So I'm going to get my calculator out. We're doing 5.9, 5.9, 5.99, etc.
So sorry,
I'm listening.
Okay, so I know they give you all these values, but if they didn't, I would just pick values close to 6.
Yes,
Okay.
Pig values a little bit less and slightly more than 6. So if you see now, I thought I was sharing the screen, but apparently I didn't do that. Let's see. So I'm going to share my calculator at this point so you can see it. So what I'm going to do now is I'm going to take advantage of my calculator powers. And I'm going to say, well, all right, I'm going to go to y equals here. And I'm going to put the expression that you got for your slope into the y equals. So I'm going to say -2 over, and then I'm going to go with, I always do that. Why do I always do that? -2 divided by, and I have 5 minus x. So there's my expression, right? And what I'm going to do right now is I'm going to go to second table set. So I'm going to go to table set, and I'm going to set the independent on ask. So set the independent variable on ask me. And what that's going to do is that's going to let me plug in the x's. So second table now, and see how my table's linked?
Yes.
So if I put in, I know they didn't ask you, but if I put in 5, it's going to give me an error because we know it's undefined at 5, right?
Right.
Now, if you put in 5.9, there's your slope. Now, you have to, if you don't see 6 decimal places, you'll have to go over to that answer, highlight it, and then down below, you'll see it.
Oh, okay.
So there's your slope, 2.222222. That's your slope.
And
That's
so
PQ.
in this case, we're not finding any of the y values. We're actually finding the slope.
Well, okay, so you could do this. So let me just do it for the first one, so
Okay.
you can see how this relates. We already did find the slope, Sam.
Mm-hmm.
As we did the fraction, remember?
Yes.
We did the general expression. But just to show you that this works, if I do it the Grant work way, okay, I have the 0.6 -2, that hasn't changed, right? And I have the function y equals 2 over, 2 over 5 minus x, right?
Yeah.
So if I want to find the slope when x is 5.9, then what I'm going to do is I'm going to generate, I know what my x is, it's 5.9, yes?
Mm-hmm.
My y is going to be whatever I get when I plug 5.9 into the function.
Mm-hmm.
So 2 over 5 minus 5.9 means that I get 2 over a negative 0.9, right? 5 minus 5.9 is a negative 0.9. Do you agree with me?
Mm-hmm.
And then, so let me just show you what I'm doing here. Let me click from there for a second. So I have 2 over 5 minus 5.9, right?
Mm-hmm.
Like so, right? And that gives me that.
Yeah.
That's negative 2.222222, right? So then, now if I take and I find the slope now, I get, so my points are 6, -2, and 5.9 and negative 2.22 whatever, right?
Mm-hmm.
So now I find my slope m. M is equal to negative 2.222222 minus a -2
I see. Yeah.
over 5.9 minus 6.
Minus 6. Oh, okay.
So m is equal to, now the negative and the -2 make it positive, so I have -2.2222 plus 2, which gives me 0.222222 over 5.9 minus 6 is a -0.1. Okay, so this is, let's do -2.22222 plus 2, skip a little step there, skip the sign change, divide by, let's see,
5.9.
divide by, yeah, I just need to find the division sign on my calculator. 5.9 minus 6. So I'm looking at that, right? And that gives me, what did I not do? Oh, it doesn't like my negative, of course. There it is. Whoops.
There's that.
Now I lost
That too.
All right, now I
Yeah.
do. And you'll see what happened.
Yeah.
Look,
I see.
and that's the same thing that you got from that.
Okay.
Because we derived the expression for the slope, so you don't have to repeat the slope calculation 6 times.
Right.
So if you put in another number, like 5.99, you get 2.020202. You see? And if you get 5.99939, you get 2.00200020. You see what I mean?
Yeah.
Now, if you do, let's do 3 nines, 4 nines, I guess. 5.9999, you get an even smaller number, 2.000200. You see?
Yeah.
Now, if you do a number that's slightly larger than 6, like 6.1, you'll get 1.81, right? But if you do like 6.001, it's 1.9980. You see what I mean? So what are your numbers really close to?
2.
They're really close to 2. So you would estimate that the slope of the secant to PQ is approximately 2. That's what you're doing.
Okay.
Does that help?
Yes. And if I were to see it graphically, then
so this is, let's see, let's do from, we're looking at 2, so let's do from, say, 0 to 3 here. And we'll scale it by half a unit. See if this gives us any indication. This would probably be, let me see what this gives us. Now that's, I kind of zeroed in on the curve, but that's what we're looking at. Now, if you look at the slope of this line, this is the point that you're looking at is, oh, but I need to take it out further because our curve was, hold on. Our point was actually 6 and -2, so I was trying to show you that it flattens, but I wasn't showing you the point that we had. So let me change the negative here, and this is 10. So we're looking at, there's your curve. Now, the point you're looking at is 6 and -2. So it's something, it's right here.
Right.
And you're looking at the slope of this line
Okay.
as you do it. And so that's where that comes from.
So that's the slope of both the tangent and the secant, like where they cross.
Okay, no, the slope of the secant, good question, but the slope of the secant changes. That's what the calculator functions say. But what it's saying is that your expression, by the way, was -2 over 5 minus x. So you get, I think I left the negative out. Now that I'm looking at it, I think I left the negative out on top. So it should be a negative number. I didn't when I did the calculation, but I did when I did the other part of it. But the slope of the secant changes.
Okay.
But what the slope of the secant approaches, what it gets close to, is the tangent. That's why you're looking at the values to see what it gets close to.
Okay.
Does that make sense?
Yeah.
So that's why you're looking at it.
Okay.
So does that help?
Yeah, it does.
But the slope of the secant always changes. The slope of the tangent at that point is what the values are approaching. But if you derive it one time, then you end up with the actual values of your equation. So let me go back into my application here. Where is it? There it is. Let me make sure I put the negative in there. Yeah, I did. Okay, I did. I left it off, but I did put it in.
Yeah, because I did the same thing in my graphing calculator and I got the same.
Yeah, I was thinking, I was just looking at it because I had left it off of but I did the math correctly. But I did it as if it was there, but I just snuck it in right now. I'm like, okay, what happened? Oh my God.
Yeah, I guess what was throwing me off is that the slope was so close to the point that they had given me.
That can be true.
Okay.
That doesn't have to, that's, because remember, at the tangent line, you're going through that point.
Yeah.
The tangent line goes through that point. So that point will be on that's why you can use that.
Okay.
But yeah, that's how it's done. But
Yeah.
use the calculator um to help you do all those calculations, and don't don't just plug it in like 6 or 8 times and and then find the slope every single time. Find one expression for
Yeah.
the slope of the secant, even though it takes a little time to do that. It takes you far less time to do that once and then plug it in your calculator
Right.
than it does to do the same slope calculation 6 or 8 or whatever times, you know.
Yeah.
Um, but you see now where it's going.
Yeah. Yeah, it makes sense.
Let me take a picture of this and send it to you. But yeah, it's not that. But now, do you believe me? All you're doing is finding the slope.
Oh, excuse me.
I promise.
Yes, I definitely I see how it's related to the I mean for at least for the tangent and secant how it's the same slope, but I think it's just like gonna take me a little bit to get the arithmetic down. You
Oh
know,
yeah,
just
no,
yeah, just to
that algebra
understand.
takes, yeah, definitely, definitely. But the part that my students had difficulty on last semester was if they give me a 0.6 negative 2 and I have the function, how in the heck am I gonna um find the slope if all I have is the function? And what I started them with is I could give you that point as xy, could I not? And then you would have y minus a negative 2 over x minus 6. Now
Yeah,
just replace the y with the function. Oh, we can do that. They're all equivalent expressions.
yeah,
And that's all you're doing is just putting in equivalent expressions. That's really all it is. It just doesn't seem like it when you're.
yeah, yeah. That's the example he showed us. Was that he had x and x squared because y equals x squared.
Uh-huh. So then it was x squared. Yeah, so that's all you do.
Yeah.
That's how those problems work. Do you have any questions about any others? We still have some time. It's 10:15. So we have a little time if you.
Yeah, let me see. There's like a velocity one.
Okay, that's another application of um, the slope of the tangent.
Yeah, it talks about the velocity and then it gives you the function itself.
Mm-hmm. Mm-hmm.
So you figure out when t equals 2, how many seconds per feet per
Oh
second.
yeah. So yeah, so it's basically the same thing. I mean, you'll learn what we're doing right now, the slope of the tangent line, the slope of the tangent line is actually something called the derivative, and so is the velocity. The velocity is the derivative of the position function. So they give you a position function, and then you're finding the derivative of that. Now, because you don't quite know how to find derivatives, you will by section 1.6 gives you the difference quotient, so you can use that. But in chapter 2, you'll learn about those. And you find all those derivatives, and then you'll do all of that using analytical methods instead of numerical ones.
That sounds tough.
No, actually, it's. I mean, it has its own algebraic pitfalls, but it's actually a little bit less work than all of this.
Mm. Yeah. Let me see if I can find maybe one that I won't be able to do on my own.
Don't ever say that. Just think, do this now.
I know, right? Let's see. I think I'm going to go to the next section. See, 1.5.
I think if I remember right, 1.5 was applications of like to
Oh, the
biology and natural sciences. So it was doing the same stuff, but it was just in applications of it, if I remember correctly.
yeah, they're starting, and 1.5 is when they start talking about the limits.
Mm-hmm.
And like when the holes in the graph and when you're reaching that limit, like kind of what we
Oh,
were doing.
continuity, right?
Yeah,
Is it continuity yet or not yet? I don't know.
or maybe continuity is
Maybe it comes
following.
later. I can't remember. Yeah, I can't remember, but it's somewhere around here they start talking about. I just remember that a couple of these sections were really long to do. They weren't hard. It was just a lot of writing. Like it was a lot of writing to do the problems. It was just like, okay,
Yeah,
let's sit here and do all the calculation.
yeah, because I'm used to teachers doing a lot of problems, like a lot of examples,
Right.
and so then I'll get the hang of how to go about doing them,
Right.
in class, and then I'll be okay. But with him, he's a little different. He wants you to understand like the
So he's doing a lot of the
concept.
theory.
Yes. And so then it's like, okay, I understand the theory and I understand that's important, but usually I learn that part on my own. So him
Oh, okay.
it's like,
Well, I can if you do happen to need more examples of a certain thing, I can send you some. I just don't want to overwhelm you because I have the work from last semester, so it just depends on what kind of
yeah,
problems you're doing, you know?
just
Because
so I can practice like for the test. That's like,
yeah.
for. So this one shows
Okay, go
uh,
ahead and share your screen again.
okay. It's one of those piecewise.
Oh, lovely. Yeah, they get a little, those get tricky. Those can get tricky with the limits. Okay. Now here you have to pay attention to the number, okay? And you have to pay attention to the side you're approaching from, okay?
Mhm.
So remember that the limit as t approaches 0 means you're looking at 0. So you have to go to 0, okay,
Mhm.
on the graph, which is where the x-axis and the y-axis meet, and you're approaching 0 from the left, okay?
Yeah.
That means you're approaching 0 from below, from the left side, right? So you'd be looking at you're approaching 0. Now it's tempting here because it breaks to say, well, I'm going negative infinity and then I break at -1, okay? But that's not 0. So go ahead and jump down to the bottom, right? You've got a hole there at -1 and then you go up close. Now, as you get close to 0, right? You're not broken at 0, are you? You see
Uh,
that?
yeah.
You're not broken. You're continuous at 0. So the limit as t approaches 0 from the left is wherever that intercept is, like a half. I can't
I
tell
think
from
it's -1.
at 0 is
Yeah, 0 is here.
Oh, is that, okay, yeah,
That's-
oh, I was looking at 1, I'm sorry. So it is broken at 0, I'm sorry. It is.
So,
So if
yeah.
you're approaching from, yeah, I was looking at the other curve. I was looking at 1. So if you're approaching 0 from the left, then you're gonna have, it's gonna be a -1,
-1.
right?
And
But
then,
if you're approaching 0 from the right, then it means you're on this other piece of the curve where you have that hole at 2 and 2.
yeah, it's 0 and -2.
Okay, so the A is going to be,
Negative.
well, A is going to be 0. You're approaching 0 from the left. So you're going to have the closed hole, right?
Yes.
Which is -2.
-1.
Negative, is it negative? I'm having a hard time.
Yeah, I know these
reading that.
graphs. I don't know why they don't make a bold line for this x-axis. They just write a T and then that's an arrow. So this is the x-axis right here.
Oh, okay. So -1. Okay. Yeah.
And
So as it approaches from the left, it's -1. As it approaches from the right, you're on this second piece, this curvy piece that kind of looks like it could be a cubic function.
uh-huh.
But you're coming down, you're approaching 0, and that's going to be this hole,
Yes.
and that's going to be -2.
2. So even though it's a hole, it's still -2.
Right, because it doesn't have to be defined in order for the limit to exist.
Okay.
What are you getting close to?
Right.
You're getting close to -2, right? Now, because these one-sided limits are not the same, we can't write the limit as t goes to 0 of g of t. This does not exist. So if an answer does not exist, enter DNE. So
yes.
capital DNE is what you're going to put there.
And the reason why is because there's 2 on there?
It's because the limit as you approach from the left, which is -1, is not the same thing.
Oh, as negative. Okay,
Yeah.
right.
If they're the same, then you can write what we call the two-sided limit without a designation.
Right.
But if you can't do that, if they're not the same, then you have to specify.
Okay.
Okay?
Okay, I get it. I'm going to go to another one just so we can
Yeah.
move. Okay. Thank you for that.
Then we have another piecewise function here. Sketch the graph of an example of a function that satisfies all of the given conditions. Okay. So they give us a bunch of graphs. Okay. So the first thing it says is, now personally, you can start anywhere you want. Okay. I like to start with whatever the function values are and then go to the limits. It's just easier for me because I feel like those are fixed points. He doesn't do that, but that's what I do. So f of 0 equals 1, right? Means that my curve is defined and has a point at 0, 1. So it should have, whatever my curve looks like, it should have a closed circle at 0, 1.
Yes.
If it
So
doesn't,
only one of those.
then it's not going to work. So right now the top left is in the running and the top right is in the running. The bottom left and the bottom right are out.
Yeah.
Okay? Now, the next thing it says, I go back to this first condition and it says the limit as x approaches 0 from the left. So if I'm approaching from the negative direction and going toward the origin, I should get 2. Well, if I'm approaching 0 from the left through values that are smaller, I'm not getting 2. I'm getting something like -1. So that's not it.
Yeah.
Okay? So it has to be
This one.
this top right
Okay.
graph.
That makes sense.
And that's how I mean, there's other ways. If they actually ask you to sketch it, your graph can look different than one of those. But
Right.
basically, you want to find the graph that fits all of the conditions they give you. Okay?
Okay.
So again, here, I would do the same thing. Look at the points that are given before you look at the limits. I just find that easier.
Yeah.
F of 5 is equal to 5. So we're looking at the point 5, 5. Okay? So the top left has the point 5, 5. The top right,
Yeah, I think
uh,
they actually all do.
this one has, all of them have that. Okay?
And yeah, they all have that -2, 3 also.
Okay, so this time they all have that. So no process of elimination here. Okay, so the limit, the first condition here says the limit as x approaches 5 from the right. The limit as x approaches 5. So first quadrant, the limit as x approaches 5 from the right should be 6. So the first graph, if it approaches 5 from the right, it's not approaching 6. It's not high enough
Right.
to do that. So the first one is out. If you're approaching 5 from the right, in the top right graph, same thing. It's too small. It's like 4.
Right.
You want to be, so the top graphs are out. Okay? Now the limit as x approaches 5 from the right on the bottom left
Mm-hmm.
is going to mean that you're at that hole, and that is 6. So that's okay. The bottom right, if you're approaching 5 from the right, it is 6. So both of these meet that first condition. Okay? Do you see that?
Yes.
One of them has a hole and it's decreasing, and one of them is increasing, but that's, so both of the bottom graphs have that. The limit as x approaches 5 from the left, so you're still in the first quadrant, but you're approaching from the left, should be 4. And the bottom left meets that condition.
Okay.
If you're approaching 5 from the left here,
It's not 4.
it's not 4. So it should be this one. So now let's make sure that our third condition is met. The
Okay.
limit as x approaches -2 from any direction should be 4. Well, if I'm approaching -2 from either the left or the right, I have a hole, but it's not the dot that I'm approaching, it's the hole. So -4, so it's the bottom left.
Yeah. So it could be this one too. I mean, if you're just looking at that side as well.
As x approaches -2. Yeah, but remember we said,
Yeah, because it doesn't meet that 5 negative.
yeah, one of them didn't meet
Yeah.
I don't remember. Yeah, but you have to meet all of the 5 conditions
Mm-hmm.
to meet that.
Okay.
You have to meet all of them. You see that?
Yes.
Then you have something similar. Okay, this is just plain evaluate the function. So this isn't even find the slope. This is just plug in the function for all the numbers. And then it says estimate the value of the limit
Mm-hmm.
at that point. So this is another way of doing it. We're not looking at the slope of the secant. We're
Right.
just plugging in the function values, which is just a bunch of grunt work.
Uh-huh.
Use your calculator, plug it in, and then you're going to look at the values around 5, and it's going to tell you based on what you put in, what your function values will be.
So what would this mean? Like to
Okay,
guess?
so when you plug this all in, right?
Mhm.
You're gonna have some values that are close to some number, just like before. The only step you're skipping between this and the first one that we did is you're not deriving an expression for the secant. This is your f of x, and your f of x is getting close to some number. So
Oh, I see.
x squared minus 5x, so it's, let's see, x squared minus 5x over x squared minus 25. So if you do, let's see, let me terminate your screen share for a second. And let me, oops, I don't have my calculator open.
So basically, whichever value it's getting close to y,
Yeah,
the y value.
yeah, I can poke it in really quick. Let's see.
Okay.
As long as I apply the, okay, so if I have x squared minus 5x, and you'll learn about this in the next section when you start doing the limits for real, when we start doing it in chapter 2. Second insert parenthesis. Okay. What? Oh, okay. That's why, because I didn't put the parenthesis in there. X squared minus, yeah.
So if you were to start taking, I know you've talked about it, but if you were to start taking math at Cerritos again, would you have to start over again or?
No, the thing is, they wouldn't let me because I've already taken it
Oh,
and I've already earned like credit for it.
uh-huh.
But that's why Professor Nickdell wanted me to embed.
Mm-hmm.
She actually suggested that I embed in the calculus one more than once, so I could feel more comfortable with the material.
Mm-hmm.
Because that was my thing. Like I didn't feel um, I didn't feel comfortable with explaining the material. And so she was saying, well, why don't you repeat it, talk to somebody and see who else is teaching it. But it kind of fell off because we had the pandemic and now we haven't been back and now we're not going to be back for a minute.
So are they not embedding tutors now?
They are. They
Oh, okay.
are. But the thing is I would have to find somebody who's 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 teaching the calculus
Mm-hmm.
and ask them if oops if they would allow me to do that. You know what I mean?
Yeah.
And she's not doing it. She's doing I think she's doing a differential equations course. So so it would be hard for me because if they don't know me, they're not gonna, you know what I mean?
Yeah.
So at 5 you get an error. At 5.1 you get like 0.505 at 5.01, you get 0.05005. You see what I mean?
Yeah.
At 5 point. So you don't need the secant approximation if, notice this isn't at, it didn't say estimated at a specific point until later. This is the other version where remember how you asked me earlier, if they don't give me a point, they just give me a number? Well, that's why you're doing it around 5. Because the limit is around 5. You're being asked about the limit around 5.
Right.
And so it gets close to 0.5.
I guess it was kind of throwing me off because it says round to 6 decimal places, but in this case, I don't need to. I would just put 0.5.
Well, no, because remember your calculator, if you look at my screen, your calculator will only display a certain amount, but if you look down below,
Oh, okay.
you get more.
Okay.
It's just that it terminates at 0.5 because look how many zeros there are after it.
So,
1, 2, 3, and then there's 499, so it would all round to that. But if you want to see the 6 decimal places, go to the Y1 part of your calculator and you'll see it.
okay, because the part where it says guess the value of the limit, if the
Yeah, so basically it's just saying what is it close to?
so I just put 0.5 for that.
Yeah, it's
Oh.
close to a half.
Okay, that's what I was wondering, because if it says correct to 6 decimal places, I was like,
Well, you could put in, I mean, I don't know how picky it is. If it was Pearson, it would probably want 6 zeros. But
Yeah.
the point is that you're gonna have,
it close to.
it's gonna be close to 1/2.
Yeah. Okay. Okay,
Okay?
I just tried it and that worked. So I just had to put 0.5. So
Does that make
yeah.
sense?
Yeah, that makes sense.
I mean, the point about doing 6 decimal places is so that you can see what it approaches.
Right.
Because if you round to fewer, you might get the same number all the time. Okay?
Okay. And they also did, I know it's getting to get late, but
We have a few minutes. Go ahead and share your screen again. I took
okay.
my application off
Okay.
the calculator. Did it help you to see that?
Yes, thank you.
No worries.
I feel pretty confident on limits now, I think.
Well, it's now you're starting to see the theory behind it a bit more,
Yes.
right? Now, this is another version of the same thing, okay? You're going to learn to evaluate this limit in a different way later, but basically use a table. Here, the only difference is they don't give you the values, okay? So you want theta to get closer to 0, right? So you want to choose values that are close to 0, like 0.01, 0.001, 0.0001, and then choose values that are slightly smaller, like 0.9. I mean, I'm sorry, negative 0.1. You know what I mean? You want to approach it from both sides and plug it in. Okay?
Okay.
And you'll get a limit for that.
And I plug that into my sine
You plug it in for theta.
for theta. Yeah.
You plug it in for theta, and you make sure that your calculator's in radians when you do it.
Okay.
So sine of 5x You can use, your calculator will use x. Sine of 5x over tangent of 4x. And then you'll plug in values and you'll get an answer from that. Okay. Now on the next one, they they give you a table, but they do it in a different way. They give you a function here, and then they have you zoom in around it. So they have you fill it in. What is f of 0.1? So you're going to plug in 0.1 to the function. Use your calculator, put the decimal equivalent right here. So instead of giving you xy, they write it as function notation. But it's the same thing that you were doing 2 problems ago.
Right. Okay.
So it's just a bunch of plug it in and figure
Yeah.
out the limit.
Okay. Let me see if I can go to the next section. I'm like, I try to use up as much as I can. Okay.
Yeah. Go ahead.
Maybe someone will steal you from me.
No, I only have 2 other students, so
Okay.
my high schooler didn't call me. I gotta call her and make sure her class went okay yesterday. She didn't call me, but now this is actually getting you started on the limit laws. Okay, this is kind of a funky way of doing it. They give you a bunch of limits. The limit as x approaches 2 of f of x is 1. The limit as x approaches 2 of g of x is negative 5. And the limit as x approaches 2 of h of x is 0. Okay? So it says the limit as x approaches 2 of f of x plus 4g of x. Okay? That's going to mean that you take the limit as x approaches 2 of f of x, which is negative 5 because they give it to you, right? Plus 4 times the limit as x approaches 2 of g of x. So this is negative 5 plus 4 times.
It's 1, right? The first one.
F of x is, oh yeah, I'm sorry. I was thinking about g of x. So yeah, 1 here plus 4 times negative 5. So 1 plus 4 times negative 5 would be 1 plus negative 20. That would be negative 19. Okay? Here it says the limit as x approaches 2 of g of x cubed. So find the limit as x approaches 2 of g of x, which is negative 5, and cube that.
Okay.
Which is negative 125.
That makes sense.
Okay. Here it says the limit as x approaches 2 of the square root of f of x. Now,
square root of 1.
Yeah, which is 1.
1.
Right?
Okay. That's pretty
So, I mean, you're going to get to real limits right now. Like here, this one. Now, there's other rules for this. Now, there's lots of rules in 1.6 about, so what you want to do here is you want to try to factor, well, first you want to try to put the number in there, but I always try to factor it first to see if the value that you're approaching is in the domain of the function, right?
Okay.
Because sometimes it's not. But if it's not, sometimes you can still find the limit anyway because factors will cancel. So if you were to, let me just do this really quick. The limit.
Because the limit itself is like a hole in the graph.
Not always.
Okay.
Sometimes. It is if the factors cancel, but it could also be an asymptote if it doesn't exist, or
Okay.
it could be a number. You have t to the 4th minus 4, so this is going to be t to the 4th minus 4. And then this is going to be, I wonder if it factors. This is 2t, and this is t, and I need a -3. So, no, I think it should work if you plug it in, because you get -2 to the 4th minus 4 over 2 times -2 squared minus 3 times -2. I'm plugging it in directly right now, which is always the first thing you should try to do.
Okay.
This is going to be 16 minus 4, and the bottom, let me see if I can do the arithmetic. That's 4, that's 8. So we have 8 plus 6 plus 2. Yeah, so I'm getting 20 over, I'm sorry, not 20. 12 over 16, if I did the math correctly. And that's 4, that's 3/4. If I did all the math correctly when I poked it in there. So, but sometimes, so initially when you start doing limits, you try to plug it in.
Okay.
If it doesn't work, then you try to use, and I don't know how far he got in teaching you all the limit laws, but sometimes you have to use quotients, sometimes you have to use conjugates, sometimes there's a lot of stuff you have to do.
Yeah.
Depending on what kind of, these first initial ones look pretty they look pretty tame,
Yeah.
actually. But some of the ones that come later might not be, like, for example, this one, 16 plus h minus 4 over h. There you're going to have to use a conjugate, because if you plug in 0 right here, you get an undefined limit.
Okay.
Okay?
Yeah, he just did one like that.
And on the next one after that, you would have to combine them over the same denominator and cancel and see if you can. So they can get a little complicated,
So
but
for the conjugate one, I would do,
you're going to do this. You're going to multiply the top and the bottom by this root of 16 plus h plus 4.
okay,
And
it's not negative in the front, or
no, the conjugate is, you see the term on the top, square root of 16 plus h minus 4? The conjugate only changes the sign in the middle.
so it'd be 16 minus h
No, the sign in the middle of the root and the number.
and the number. Oh, right. Okay.
You don't change the sign under the radical, you change the sign between the radical term
And
and the constant.
okay. Yeah, I don't think I've dealt with one like that before.
No, that's new. And I mean, you've rationalized before, and you've
Right.
rationalized using conjugates, but you probably never rationalized the numerator before.
Yeah, usually they don't.
We always rationalize denominators in algebra, but in calculus, we rationalize numerators quite a bit
Okay.
for situations like this, because what happens is when you rationalize the numerator, you end up with an expression where you can get rid of the h that's causing you problems.
Okay.
Okay, I think we're
Yeah, it's
at,
about 10:50.
yeah, we're at time.
Okay.
But I'll work out this limit and I'll send it to you.
Okay.
So check in with me after class or whenever you're doing your home, maybe later tonight, and let me know how the homework is going.
Okay.
Okay? But you should, 1.5 is a bunch of plugging in and finding
Yeah,
finding slopes. It's a lot of busy work, but it's trying to get you to see what the limit means.
right.
Okay?
Okay. Thank you so much.
And I have remind me, I have a limit techniques flowchart for finding limits algebraically, like in this section, that would probably help you. So
Okay.
we'll talk about that when you come back. All
Sounds
right.
good.
All
I know.
right. Take care, Sam. Let me let you go because I know you got to run.
I know. The class, he always gets there like right before 11, so I guess I'm pushing it. But also, I wanted to see when you would be available to go through maybe, because I think it helps me a lot when we went through his
Go through the
lectures.
lecture? Sure. Yeah.
Yeah.
So if you just text me after class,
Okay.
you said you get out around what, 4 or
Uh,
something?
no, we get out at
3.
1:50.
Oh, 1. I thought it was for some reason. For some reason, I was thinking your class ended at 3:50. I don't know.
Okay.
Yeah. So text me when you get out, and then we'll see if we can set it up and go through it.
Okay.
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 All right. I'll talk to you soon.
All right. Thank you.
Bye.
Bye.